So remember that if you have a curve, you can find the unit tangent vector to the curve, and also you're interested in finding a normal vector to the curve at this point. We're going to name this n of t. So how do we define that? Let C be a smooth curve. It means that the derivative is continuous and it's not zero. Let t of t be the unit tangent vector. Then the vector that is perpendicular to the curve at given point is going to be a normal vector, and we're going to use a unit normal vector. Make sure the length is small and it is 1. At any point where the curvature is not 0, we can define a unit normal vector. This unit normal vector is defined as follows. We're going to use the unit tangent vector. N of t is equal to the derivative of the unit tangent vector divided by its magnitude. The norm of the derivative of the unit tangent vector. The vector that is perpendicular or orthogonal to these two vectors is called the binomial vector. So let's introduce that guy as well. Note that a vector that is perpendicular to both t and n is called a binomial vector. Let's take a look at the following example. In this example, I ask you, find the unit normal vector to the following helix. To the helix RT, which is given to us as cosine t, sine t, and t. Well, we just need to follow this formula. What is t prime of t? First of all, we need to find the derivative of r. R prime is equal to negative sine t, cosine t, and 1. The magnitude of r prime is equal to the square root of negative sine squared plus cosine squared plus 1 squared, which is 1 plus 1, or square root of 2. Well, remember the formula for unit tangent vector. It is equal to r prime divided by the magnitude of r prime, which is equal to 1 over square root of 2 negative sine t, cosine t, and 1. Now you can take the derivative, because we need the derivative. T prime of t becomes 1 over square root of 2 negative cosine t, negative sine t, and finally 0. Very good. Now, if you find the magnitude of the derivative of the unit vector, this guy is equal to, here we have 1 over square root of 2 times the square root of negative cosine squared plus negative sine squared plus 0, which is nothing but 1. So this magnitude is 1 over square root of 2. Now let us take these and use the unit normal vector formula, t prime divided by the magnitude of t prime. So here we have 1 over square root of 2, negative cosine t, negative sine t, and 0 divided by 1 over square root of 2. Well, the result, n of t, is vector negative cosine t, negative sine t, and 0. Now, at each different t value, we can find this vector, which is perpendicular to the curve.